Welcome to AI Frontiers. Picture this. You wake up tomorrow morning, and your smartphone camera doesn't just capture photos. It understands the three-dimensional structure of everything it sees, generates missing parts of scenes with photorealistic accuracy, and adapts instantly to new environments without any additional training. What sounds like science fiction is actually the cutting edge of computer vision research happening right now. Today we're exploring breakthrough discoveries from 16 computer vision papers, published on August 8, 2025, revealing how machines are gaining human-like visual understanding capabilities through revolutionary advances in self-supervised learning, task-specific architectures, and generative modeling approaches. Today's journey takes us through a comprehensive exploration of how artificial intelligence is revolutionizing visual understanding. We'll be examining 6 dominant themes that are reshaping computer vision, from efficiency innovations enabling mobile deployment to breakthroughs in autonomous driving and medical imaging applications. Our investigation reveals how machines are learning to see without human supervision, how task-specific architectures are challenging universal transformer dominance, and how generative models are transforming image manipulation detection. We'll discover real-world applications that demonstrate the practical impact of these advances, examine methodological innovations driving progress, and explore what these developments mean for the future of visual artificial intelligence systems. Computer vision represents one of artificial intelligence's most ambitious frontiers, seeking to give machines the gift of sight that goes far beyond simple image capture. This interdisciplinary field fuses mathematics for understanding geometric relationships, physics for modeling light interactions with surfaces, neuroscience for insights into biological vision systems, and engineering for building practical real-world applications. The field powers the face recognition that unlocks your smartphone, enables autonomous vehicles to navigate city streets safely, assists medical professionals in analyzing diagnostic scans, and provides the foundation for augmented reality systems that seamlessly blend digital objects with physical environments. Modern computer vision has evolved dramatically from early edge detection and template matching approaches to sophisticated systems capable of contextual scene understanding, spatial reasoning, and creative content generation. The first major research theme focuses on efficiency revolution in visual artificial intelligence, where researchers are achieving remarkable performance improvements while dramatically reducing computational requirements. The adapt-infer framework exemplifies this trend, introducing adaptive token pruning for vision language models that achieves a substantial 61.3% reduction in computational latency while maintaining over 92% accuracy. Similarly, the TSNet architecture for camera demoscene demonstrates how innovative lightweight designs can outperform their heavier predecessors using significantly fewer parameters. This efficiency revolution is driven by the growing demand for mobile deployment and edge computing applications, where sophisticated vision systems must operate within strict computational constraints. These advances prove that performance and efficiency are no longer mutually exclusive goals in computer vision system design. The second and third themes center on multimodal integration and self-supervised learning approaches that are transforming how machines understand visual content. The Q-Click framework represents multimodal integration advances by unifying vision-language understanding for video quality assessment, while DreamV combines visual content processing with natural language instruction comprehension. Self-supervised learning is eliminating traditional annotation bottlenecks through innovative approaches like the mask and match framework, which uses progressive spatial masking and contrastive learning to achieve superior performance without manual annotations. These cross-modal understanding capabilities mirror human sensory integration, where multiple information sources combine to create comprehensive scene understanding. The success of learning from unlabeled data addresses one of computer vision's most persistent challenges, the expensive and time-consuming process of creating high-quality labeled training datasets. The final research themes address robust learning from imperfect data and specialized application development. The MCA framework tackles real-world deployment challenges by handling datasets with imperfect annotations, recognizing that practical applications rarely have access to perfect training data. Generative modeling advances are demonstrated through Swift Video's unified framework for few-step video generation, while specialized applications are exemplified by GMF Drive's end-to-end autonomous driving architecture and medical imaging advances in trochleoplasty planning. These domain-specific solutions reflect the field's maturation and growing demand for reliable performance, in particular, application areas. The emphasis on robust learning acknowledges that real-world visual data is often noisy, incomplete, or inconsistent, requiring algorithms that can adapt and perform reliably despite these imperfections while maintaining high-performance standards. 5 breakthrough discoveries are fundamentally reshaping computer vision research and applications. Wang and colleagues achieved new state-of-the-art performance in end-to-end autonomous driving, demonstrating that task-specific architectures can outperform general-purpose transformers in both performance metrics and computational efficiency. A second breakthrough shows that joint learning of seemingly contradictory tasks can actually benefit both outcomes when approached correctly, challenging traditional assumptions about task interference in multitask learning scenarios. Generative models are proving superior to discriminative approaches in forensic applications, with diffusion-based methods achieving substantial performance improvements in image manipulation detection tasks. Lightweight architectures are simultaneously improving both performance and efficiency, disproving the common assumption that better results necessarily require more computational resources. Finally, self-supervised learning approaches are surpassing fully supervised baselines in complex recognition tasks, suggesting a fundamental shift in how visual understanding systems can be trained. Methodological innovations are driving unprecedented progress across multiple dimensions of computer vision research. State space models are emerging as powerful alternatives to transformer architectures, offering linear computational complexity while maintaining the ability to capture long-range dependencies essential for visual understanding tasks. Progressive learning curricula break complex recognition problems into manageable subtasks that can be learned incrementally, leading to more robust representations and stable training dynamics. Multimodal fusion architectures are developing sophisticated methods for combining information from different sources, leveraging complementary data types to enhance overall system performance. Distribution-aware learning methods recognize that different tasks may have fundamentally different statistical properties requiring specialized treatment approaches. Generative discriminative hybrid frameworks demonstrate the benefits of combining traditionally separate paradigms, leveraging the strengths of both generation and discrimination capabilities within unified system architectures. The GMF-Drive framework by Wang and colleagues represents a revolutionary approach to end-to-end autonomous driving that fundamentally rethinks sensor data processing for navigation decisions. The researchers addressed critical challenges in autonomous vehicle development by replacing histogram-based LiDAR representation with geometrically augmented pillar formats that encode shape descriptors and statistical features, preserving essential three-dimensional geometric details for accurate spatial understanding. Their hierarchical gated Mamba fusion architecture replaces expensive transformer computations with spatially aware state space models, incorporating directional sequencing and adaptive fusion mechanisms to capture long-range dependencies with linear computational complexity. Experimental validation on the challenging NABSIM benchmark demonstrates new state-of-the-art performance while significantly outperforming previous methods. This work challenges the prevailing assumption of universal transformer superiority, opening new avenues for developing specialized architectures optimized for specific computer vision tasks requiring spatial reasoning capabilities. The UDITML framework by Me and colleagues introduces a unified generative approach that represents a paradigmatic shift in image manipulation detection from discriminative to generative methodologies. This work addresses the critical challenge of detecting and localizing image manipulations in an era where sophisticated editing tools make distinguishing authentic from manipulated content increasingly difficult. The methodological innovation centers on using diffusion-based generative models for manipulation detection by learning the underlying data distribution of authentic images, enabling identification of deviations that indicate manipulation. The framework incorporates class embedding mechanisms and parameter sharing designs that allow seamless switching between different task modes without additional components or trading overhead. Experimental results demonstrate substantial improvements, achieving average gains of 9.66 and 4.36 F1 points for unconstrained and constrained manipulation localization tasks, respectively. This work opens new research avenues in computer vision forensics by demonstrating that generative models can be effectively applied to traditionally discriminative tasks. The Mask and Match framework by Mitra and colleagues presents a self-supervised approach for handwritten mathematical expression recognition that tackles one of document analysis' most challenging problems. Mathematical expressions involve two-dimensional structures, varying symbol scales, and complex spatial relationships that make them particularly difficult for traditional recognition approaches. The framework consists of three carefully designed stages: pre-training an image encoder using global and local contrastive loss functions, training a novel supervised attention network using progressive spatial masking, and supervised fine-tuning with transformer decoders for LaTeX sequence generation. The progressive masking curriculum starts with simple patterns and gradually increases complexity, encouraging robustness to missing visual information while building semantically meaningful representations. Experimental validation on chroming benchmarks shows this self-supervised approach outperforms both existing self-supervised methods and fully supervised baselines, demonstrating that self-supervised learning can be effectively applied to tasks involving complex spatial relationships and hierarchical structures with implications extending beyond mathematical expression recognition. Looking toward the future, several exciting research directions are emerging from these breakthrough discoveries. The success of task-specific architectures like state space models for spatial reasoning suggests a potential shift away from universal transformer architectures toward more specialized designs optimized for particular types of visual understanding tasks. The growing effectiveness of self-supervised learning approaches indicates movement toward systems that can learn sophisticated visual representations without extensive manual annotation, potentially democratizing access to advanced computer vision capabilities across diverse application domains. Integration of generative and discriminative approaches is opening new possibilities for systems that can both understand and create visual content, leading to more versatile and capable artificial intelligence systems. Increasing emphasis on efficiency and mobile deployment suggests that future computer visual compatible constraints driving innovation in lightweight yet powerful architecture. This research was synthesized using advanced language models including GPT and Claude Sonnet 4 2025-0514, with audio generated using DeepGram text-to-speech technology and visual elements created using Google image generation systems. The content has been carefully reviewed by human computer vision experts to ensure technical accuracy and clarity, though potential oversights are acknowledged despite the thorough review process. The synthesis process involved analyzing 16 research papers from the archive preprint server, extracting key methodological innovations, identifying breakthrough discoveries, and contextualizing findings within broader computer vision research trends. This collaborative approach between artificial intelligence systems and human expertise demonstrates how advanced language models can assist in processing and synthesizing complex technical research while maintaining scientific rigor and accuracy standards essential for educational content. Join the AI Frontiers community by subscribing to our YouTube channel for the latest research discoveries and expert analysis of breakthrough papers and emerging trends. We provide weekly deep dives into cutting-edge artificial intelligence developments, facilitating community discussions about the future of artificial intelligence and serving as your gateway to understanding tomorrow's technology today. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archivepreprinserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archivepreprinserver.org.